Hi, so I'm Matt, and this is glycolysis. So with glycolysis, we can actually start from two different spots. If we're talking strictly glycolysis, then we start at step one, where basically we need to burn an ATP in order to get into the molecule. This phosphorylation of glucose through the by ATP. However, if we're starting with glycogen, we basically skip step one, and we don't need to burn that ATP in order to get there. All right, so this first step, so basically steps 1 through 3 are the energy investment phase of glycolysis. So if we're starting at step 1, hexokinase is the enzyme that's going to help create glucose 6-phosphate. And then from there, there's going to be a rearrangement of basically PGI, or phosphoglucose isomerase. It'll change the structure without actually changing the formula. And from there, we move on to the fructose 6-phosphate. From there, PFK, or phosphofructokinase, which is our rate-limiting enzyme, basically from there, it's going to separate this chain into two separate chains, GAP and DHAP. From here, this will start the energy generation phase. So in this phase, basically, we have two chains running, doing pretty much the exact same thing, or very similar, all the way till we get to the end. So from here, we have oxidation, which is going to be followed by phosphorylation, which is going to produce two NADH molecules, and two high-energy BPG molecules. And so the enzymes here are the triose phosphate isomerase, or TIM, and the glycerol, I just erased part of it, 3-phosphate, or dehydrogenase, so the GAPDH. And from there, we're going to go down to the bisphosphoglycerate. And here we're going to gain another ATP molecule, and the phosphoglycerate, or PGK, is going to move us down to the phosphoglycerate, and then again from there, the PGM will move us down to the 2-phosphoglycerate. So we went from 3 to 2, and here we're going to create an H2O with the help of the enzyme enolase, and then we're also going to move down to the phospho-N-O-pyruvate, and we're going to gain another two ATP molecules at this stage, and the enzyme pyruvate kinase will then give us our pyruvate at the end. Now, like I said before, since we split it up into two separate processes, we're actually going to gain 2 pyruvate at the end. From here, depending on what's available, whether we have oxygen available or not, if we have oxygen available, we're going to move on to acetyl-CoA, and then we'll move into a separate step altogether. And in a separate video, I'll talk about the Krebs cycle. And if we don't have O2 available, then it'll create lactate. So overall, with this glycolysis process, we're actually gaining, if we start from step 1, we're gaining a net ATP of 2. If we skip step 1 and start with glycogen, then we'll have 3 ATP, since we don't actually have to burn the first ATP to get into the cell. And that's pretty much it in a nutshell.